when you view this PowerPoint, keep in mind that I threw this together 2 years ago in an hour when Barry Skalski said, hey, dude, let's do a septic discussion at bar camp tomorrow. So, and it actually went very well then, and with COVID and everything's been a mess. But the education committee asked if we would do it again because it was so well attended then. And so, you know, on one hand, it's at that time, it was talking about the new and improved health department because some big changes had taken place in the health department. But what also occurs to us is that a lot of people in our industry simply are overwhelmed oftentimes and don't really understand what's going on with regard to septic systems and how they function and the purpose and all that good stuff. So what's awesome is that although I know a little bit about all this stuff, we have some really, really fantastic people here to help us, the least of which is Shane McBurnett. For those of you that haven't met him or used him, I would say he's one of our, he's become one of our go-tos in the county for doing inspections. And he does it the right way, and he knows the rules as well. We're very fortunate to have Mark Espic from the county health department, who is, let me make sure I get these titles correctly, the director of environmental health, and a person that is his assistant is by the name of Brett Davis. I believe both of you are online, Mark? Maybe they're taking a smoke break.
No, they're taking off mute.
Yeah, here we go. We're here.
Awesome, they're there. Fantastic. Thanks, guys. So, and that's really a huge treat. And I think all of us, you know, if we were all here, we'd give them a round of applause for taking a minute out of their day. I can only imagine the nightmares that have been going on with COVID and everything else for the health department. But to be here and to answer, you know, literally from the governing entity that concerns this entire topic, questions, you know, that we might have. So from a standpoint of ground rules, we are going to do some questions like as we go through this, because there are a couple of slides where we're really gonna dumb it down full 101. I know some of you have been through this a million times. Some of you may have been on site when the new tank and field system is being installed. And so I don't want to belittle anyone's or insult anyone's intelligence. But, you know, I think education helps all of us. And a lot of times we're afraid to ask what we think might be a stupid question. So we're going to just really start from the beginning when it comes to that. So we want that to be interactive and ask some questions. What we want to do, however, though, to respect Mark and Brett's time, is to try to stay away from getting into specific instances that are happening right at the moment. And maybe you're arguing with a septic installer, or he's complaining about, you know, he's dumping some blame on the county or something like that. We're going to stay away from those specific situations, but you are going to have the method and know how to get a hold of these guys and have those discussions with them on an appointment basis. When they've got the file out, then they know what they're talking about. And along those lines, there was a time, this was more in the early to mid 2000s, when the health department was kind of looked at like the evil entity down at the county city building. And to some degrees, they were. Mark would even agree, you know, off camera, that there was some stuff going on at the time that made business a little difficult to do down there. Some of that was circumstantial, some of it was the players involved, what have you. But since what year, Mark?
2018.
2018, management has changed. The health department is there to help us protect groundwater in the county and protect our health, and that's what they're all about. They're there to help, and if you approach it from the right standpoint, they are extremely helpful. So, Carla, we can go ahead and hop into it. You can just go to the second slide. So the purpose of the health department primarily is for public safety with regard to human health, okay? So I wanted to just kind of point out the fact that you know, as realtors, we get a little hung up on what's going on in our little world. And oftentimes we're not cognizant of the fact that, you know, these people have other things they need to worry about. Lead, radon, drinking water, food vendors, pest vectors. Again, I can only imagine what this year's been like with COVID. Typical day might include, you know, trips to the mayor's office, hearing from the mayor's office, calls from FEMA. I mean, these are all just examples of what goes on. In fact, 2 years ago, when Mark and I met to talk about this presentation a little bit, he literally was getting texts from, I don't remember, probably wouldn't want to say it on air anyway, a facility where high density living facility where there was a water problem and people were getting sick, like right there. And he was dealing with this while we were having our discussion at breakfast. And he was like, I gotta go, because it was literally a public health emergency at that moment. So when you're reaching out to these people, just try to be, you know, a little open to the fact that maybe they're not gonna fire back our calls in 2 minutes, but if they're not available, they are gonna get back to us. Carla? So to kind of give an idea of what we're going to focus on today, because this is from a filter's perspective, we're going to talk about, you know, the anatomy of septic systems, when they can be repaired, when they have to be replaced. Next slide. You can tell we practice this a lot, right? We're going to talk about threat aspects versus cautionary aspects. Next. Technical failure versus full system failure, and know who to call and what to ask when you do call. And all of this is wrapped around the idea of protecting our water source, okay? We're not, when you think about septic systems, try not to think about what's happening with the stuff you don't want when you're just getting it out of the house. That's a byproduct of the fact that we're trying to protect our drinking water. And if you look at it from that perspective, a lot of rules and the way we're told to do things, and the way these systems are designed to act are for that purpose, okay?
I tell people that in most cases, we're drawing our drinking water from the same site we're disposing of our waste. That's the reason why we have all these rules in place, to make sure both mechanisms are safe, protects public health, water, and just about everything you can think of that's going to keep us alive.
Really, because fundamentally, it's a bad idea. But we got to do something with it. And as you'll find, we can't have it laying on the ground. So, next slide, Carl. And it went away. There we go. Okay. A septic system is simply to dissipate wastewater. Everything that we do in our homes, whether that's dishes, laundry, toilets, showers, sinks, washing, brushing our teeth, whatever, we've got to get that out of the structure. And the reasons for that would be, A, we don't want to smell it. We could dump it out on the ground. That would be an option, but then it would smell. We could just pump it into the ditch out at the end of the subdivision, and that would be fine, but we'd be contaminating the water supply. And one of the things that we absolutely cannot do is polluting any kind of a public waterway. So the reason we bring those points up is because when we start talking later in this presentation about the methods of inspection and the things that are looked for, these points are going to come back up. Oh, yeah, and not backing up into the structure. That's a bad one. Yeah. So, next slide.
We don't want poop on the ground, we want poop in the ditch, or poop in the house.
No, we can't just dump it in the house. So when we think about methods of doing that, okay, a bucket would work, but we still have to dispose of it. Latrines and outhouses were something that were used back in the Roman days, and then public restrooms actually started in the Roman days, where, you know, public health and the issue of human waste was definitely something that was thought about early in the evolution of humans with regard to this is bad and it breeds disease. So then it got to the point where we actually had private toilets in our own homes, which now has led to what we would consider the excessive water use method. For instance, has anyone ever been, I can't get a show of hands because nobody's in the room. For any of you that have ever been to the Caribbean or to an island resort, oftentimes if you're off the beaten path, you are asked to what? Not flush the toilet any more than you absolutely have to. And the reason is that they are conserving water, okay? And we'll get into some of these other things that contribute to septic system failures, but at the end of the day, it has to do typically with overuse and oversaturation. And that's just unfortunately where we're at. So next slide, please, Carlin. Okay, now we're going to get into, and we really want to start at the beginning and really dumb it down. And people feel free to unmute, or apparently there's a chat function with Carlin where you can type in your questions and she will ask them in a moment where he or I aren't running her mouth. And we're really going to dumb this down. So in a basic typical system, and we'll get into variations as well, you know, there is drain pipes in the house that are all hooked to a larger exit pipe to go, and you'll see it. It's always that one that's about 4 or 5 inches across with a big screw nut on the end, because that's where they'll take it off and run a thing through to clean it if need be. That goes out through the foundation into some sort of a tank, okay? And without getting into details, which we're going to do in a minute, it has a method of intentionally leaving the solids in the tank, and the liquid is therefore allowed to leave without solids and go out to what we call a leach field or a absorption field to dissipate the liquid. Now, the way that that's done is broken down further. Do you want to talk about the anatomy of the tank?
Yeah, we can talk about it.
Okay.
After all your wastewater, everything that's produced in the house has to be stored in the septic tank to trap there. The septic tank that vesicle is designed to trap and store the solids. Over time, the solids settle out, and what's in the liquids, suspended solids, the longer you allow the tank to sit, the more suspended solids settle out of the water, and then you treat the water going out the outside. So tanks, to function correctly, they have 2 devices in there, mainly an inlet baffle and an outlet baffle. The inlet baffle is designed to direct the solids and the waste to the bottom of the tank. And the outlet baffle is designed to siphon the liquids that have less suspended solids that go out into the distribution field. So when one or both of those are missing, you have turbulence in the tank. And when there's turbulence in the tank, you have more suspended solids getting into the liquids. And when you get it out to the field, those suspended solids will actually clog the soil. So that will start the soil biomat formation and decrease the absorptive capacity of the soil. So the tank is really important to make sure we maintain that and have those particular functions that are in there to the liquid, what I call liquid separate. The fats, oils, and greases go to the top, called fog. The solids go to the bottom, and the middle is treated. So anytime you use water inside the house, that volume of water goes into the tank and it displaces equal volume going out. So the idea is the water stays in the tank about 48-ish hours. And so water comes in, water goes out, but it has time to treat. If you pump the tank too often, you're going to get too much disturbance, turbulence. If you pump the tank too infrequently, 10, 15 years, you get solids build up. So what we look for is whether the tank's been properly maintained as an inspector. If it's got more than a third-ish of solids in the bottom, you don't have enough volume, so you can have the liquids or suspended solids precipitate out. So basically, you need clean water going out the other side. The cleaner the water, the longer your absorptive area lasts. That's pretty much how that goes.
Okay, so for go back a slide, Carl. We're still on the one before this for a while. On this particular slide where they're talking about the scum line,
yeah,
that would be another term for the grease and wax and things that float.
Yeah, the floatables.
Okay.
Scum, or technical terms, fog, fats, oils, and greases. That's the gooey, nasty stuff on the top. When you open the tank, oh, that looks bad. that really is not that bad. It's only bad when it's really thick.
How do you, from a standpoint of the septic inspection forms that we see in our world, the two-page thing, what is that listed as? What's the word?
Scum.
Scum.
Yeah, okay. More than 5 inches of scum.
Okay. All right. So that's a cool thing. Now we know what we're talking about. It's things that would float on the water, oils, fats, okay, grease, right. When we talk about sludge, that would be the solid.
That's the solid.
Okay. Yeah. Okay. So oftentimes when people talk about pumping their tank, you know, a lot of times they're just doing it just because I don't really want somebody else's poo in my tank. It grosses me out. Is that really a legitimate thing if it doesn't need it based on the inspection?
I tell a lot of times people tell me, take your poo when you go. But that if the tank is functioning as it should, then there's really no reason to pump it out. Because all you're going to do is disturb it. There's oftentimes you hear, well, I pump my tank and my leach field failed. Well, they got rid of all of the solids and everything out of the tank. And during the refill, you have these baffles that still can get those solids out as the tank refills. You should probably, once you pump it, fill it back with water and then start using solids. Because that way you're not, when you get all your solids in there and the tank's not full, these solids are going to flow and they're going to go under the baffle wall and out the pipe or out the baffle, the plastic baffle. And so that'll add sludge to this leach field in a shocking way, just a lot of volume right away. So I try to tell people, try to fill it with water. I know it sounds like a waste of water, but the septic tank is going to be full all the time. It's going to be right at.
That's how it's designed to operate. It's full.
Yep. It's the liquid level will be at the bottom of the outlet pipe, which is called the invert of the outlet. The inlet should always be at or higher than the outlet. Right. Because if it's not, then the sewage goes back into the house, and that becomes one of the failures of
right. Although that's a method of storage, it's not a sustainable method.
I tell people
that's a joke. So what about when you guys run water when you're inspecting a tank? What's the point of that? What do you do that for?
What we're doing is trying to see if the absorptive area is capable of handling. In this case, this county is 35 gallons of water. And what it does, I take pictures of the tank to see what the static level is initially, and then we run the 35 gallons of water, and that's all faucets 35, all faucets cold, everyone in the house for about 7-ish minutes. You got 5 gallons of water production as well. So you're 35 gallons of water-ish. You watch it through the tank, and then while it's running, I'm looking at the absorption field to see if there's any saturation. Then I go back.
It's like if water's bubbling up somewhere. Right.
So if it's not exiting the tank like it's supposed to, or the soil absorption area is not taking like it's supposed to, that's a cautionary issue. You look at the absorption area, see what's happening, both look at the soils or just with the probe, evaluating the actual soil condition.
And you're also looking to see if water's running back in the exit pipe, right? Because that would indicate that the absorption field is saturated or full.
It's having trouble. Right. So I always shut it off. If there's a problem, it rises, then we shut it off, no matter what it takes.
Ooh, presenter's phone went off. Sorry. Well, go on.
Yeah. So I like that. A state inspector does not like the water test. They don't encourage it. I personally like to see some water go in the tank so we can see what it looks like as operation. Sure. Doing a hydraulic overload or too much water is not a typical thing that you should do. Unfortunately, when I come there after whole house inspectors, we got to wait because they flood us with too much water.
Well, oftentimes, right, they're checking all the drains and everything. Okay, so when we talk about these baffles, what do these tanks look like? What are they made out of?
Well, these days there's a couple of varieties. One mainly concrete, and there's a lot of. They're usually rectangular, 4x8.
Just a big concrete box.
Just a big concrete coffin. Oh, somebody's got one. And then there are the poly tanks or plastic tanks are accepted, and the county will have a list of the accepted tanks.
Okay.
They have to be built a certain way. They have to have certain structure. They have to have certain strengths. They have to be able to be buried and not crushed.
Sure. So well, we rely on the contractors that they're doing the right thing with all that.
Exactly.
But like this inlet baffle, is that something that's like part of the tank, just like molded into it, or is that something that gets bolted in after the fact?
Both. There are tanks that have concrete baffles already built within when they do the form, and then there are tanks that you add them while you do the install. You glue them in. Different types of baffles. Some use T baffles. Some baffles have actual filters in them on the outlet side. But the baffles are they sound frivolous, but they're really key to keep turbulence down in the tank. They're really important. A lot of people don't like the inlet baffle because it causes clogs. Well, my argument to that is properly train the users so you don't have that.
So you're not flushing bath towels down the toilet. Right, exactly.
It should function fine if you don't use.
Because there are times where we get an inspection report that'll say something like, you might have a concrete tank that's 30 years old, it's still functioning, but the inlet baffle is gone. Where did it go? Do they just fall down in the thing? I mean, do they just deteriorate?
Sometimes, and I don't want to point fingers, there are different methods of knocking it off.
Yeah.
The glue not properly glued, or it's in fact old, it breaks, the ceramic part does break. And how
hard is that to repair?
Not hard at all.
Bingo.
It's easy.
So the point of my leading questions to Shane is that, everything's fixable, guys. Okay, that's a lot of what we're trying to do here is educate. Just in looking through the registered participants, we got some people who've been doing this 20 years, and we got some people that, some names that I quite frankly don't recognize. I look forward to meeting you. And it helps us all to be educated in these things and know what it means when we talk about an inlet baffle missing, instead of just going, what the heck is that? And what do I do about it? You can understand that these things are fixable. And there are contractors that do this. This is some nasty work. It is not pleasant.
Don't ask me to do it.
Right.
That's a no.
But any of our, I believe any of our septic installers in our market, this is the kind of stuff they're doing all the time, guys. So, and we'll talk more about types of system failures in a little bit. But the thing to remember is that, again, everything's fixable, and it's not always the sky is falling, we need a whole new system. There are times where a system works fine, and we simply need the tank replaced because the tank is not holding water anymore. There's times where the tank is adequate and the field system, the absorption field needs replaced, those kinds of things. Carlin, is that slide still up or not? I can't, I'm not seeing it.
No, it's not. Do you want to back up now?
Yeah, I think it's a good visual for folks as we're using the words. And since I can't get any nods from the audience, I'm just going to say that's what we're going to do. So, yes, we did. We got 2 nods. Fantastic, guys. So there are different types of tanks. We talked about that. With regard to tanks, what about some of these situations when we hear about a pump? Okay, and everything that goes along with that. We're like, why is there a pump? This is all supposed to, in this visual, in this slide that's up right now, everything's happening by gravity. Okay, and in a perfect world, that's great. But Blair Hills is on hills. There's low lying areas where we need to talk about a mound system. We'll talk about that leach field in a minute. But talk about a pump. What is a pump?
Well, basically, it's called an affluent pump. What it does is it's designed to pump sewage. And when those tanks are installed with those pumps, it's because there is some mechanism out away from the tanks that require a different type of distribution of the liquids. Either it's too high,
usually it's uphill,
or the soil is not adequate enough below it to treat properly, so you have to build above, or you have to dig some stuff out and bring it up. So there's different systems.
Or go far away.
Or far away.
So does that just go in the septic tank on this visual here?
They could, a lot of them in the past adapted, regular septic tanks with the fluid pumps, but they have those tanks. They actually make tanks specifically for that. The plastic tanks will have a little place where it can set. The concrete tanks may or may not have a little place for the pump to set. But there's a specific way to put the pump in and how to wire it and how to plumb it, and the pump itself it has to be designed specifically for that particular practice.
Right. Which
Length
again, we would assume our contractors that are installing this stuff are doing that.
Oh, yeah, because the health department.
Because the health department's making sure of it, and if they don't, you know, they're gonna have to fix it, whatever. So we don't, I just want people to understand the words, you know what I mean? So if this system here that's on this slide had a pump, where would it be? Typically, there would be a dosing tank before the actual effluent tank, correct?
No,
Before the septic
it
tank.
would be after the septic tank.
Oh, after the septic tank.
So you have all your septic traps and stores all the solids. And then you want cleaner liquids going into the dose tank. And then from the dose tank, it pumps to the, whether it's a direct manifold system or whether it's a D-box or something different. There's other systems out there that they're different as well. So the dose tank, that one, there are people that, well, I gotta pump my dose tank. You should not pump, you shouldn't pump dose tank.
If you have to pump your dose tank, something's wrong with that. Right.
There shouldn't be it.
So wasn't it neat the way I asked you where it was gonna be in the wrong place?
Yeah, you did that.
Now, so everybody understands now when you see that there's a pump or better yet, when you're showing a home and you're looking in the backyard and you see this little gray box sticking up with a little siren and a red light on it, that's usually pretty indicative that there is a pump on that property. And that's because either the leach field is higher or so far away, or maybe had to be replaced and put around the other side of the house. There's all kinds of situations for that. So that's just more of a you know, FYI kind of thing. Now, when it comes to the leach field, explain what that, you mentioned a D box, and that stands for distribution box. Explain what that does and then what happens after that.
Well, it depends on the type of system, but basically what you have is all the liquids, hopefully suspended free, no solids in it, will go to a mechanism that's designed to equally distribute the liquids. You have to have equal distribution. So the distribution box is a container that takes all the liquid from the tank, whichever it is, dose tank or a septic tank, and it allows the water to rise slowly, and it feeds the pipes that go out. So most trench systems, all trench systems are connected to a D box, and they have their own pipe, own access to the D box. So if you have 5 trench system, you have 5 pipes going out of the D box. That liquid is to rise in that D box and hit all 5 pipes equally, so it all trickles out evenly. Beyond that, you have trench, and there's multiple configurations of trenches. They're all 3 feet wide in the ground, some gravel, some rubber aggregate, other things called chambers, more commonly known as infiltrators. Those are the ways to distribute the liquid into the ground, allow the soil to treat the water and dissipate or get rid of it. So the D-box is incredibly important as well, because if it crushes, it can block stuff back into the house. And unfortunately, the D-box is kind of the weakest link in the whole project.
Right.
Yeah, they're always broken, they're always crushed. So the plastic ones are not that strong. And there's always problems with the D-boxes. And so we got to look at that, because that definitely affects whether the water gets to the absorption area or backs up into the house.
And again, fixable. The distribution box is
and some counties
3 feet by 4. I mean, it's just not a big thing, right?
Some counties require a permit to fix it. Some counties don't. So you got to make sure if you're going to go to the D-box end and do something with that, contact the health department, ask them whether or not you need to have a permit for that.
Very good. You mentioned the pipes. What are the, if it's pipes like what we typically see in older systems, and oftentimes what gets installed today? What do those pipes look like? What's the magic there?
Yeah, they're just the typical pipe and gravel system is a certain scheduled pipe that's required, but in the county makes sure the health department makes sure you get the right
That's a certain thickness.
Yeah, thickness. And then they go out of the D box 6 inches off the gravel bottom, and it's 4 inches of gravel around, 2 on top. So you have 12 inches of gravel by 36. And the trench length and number is dependent on the soil type based on soil analysis and the specification requirements by the county. Some counties have different requirements. Some have more strict. Some use the code 1994-10 right up as it's supposed to. There's another method where a pipe comes out and it goes into what they call infiltrator or chambered systems. These are louvered systems, really easy to put together, and that distributes the water. And those are they do the job. They do a different way of distribution of the water.
Yes, from what I've seen, where some of us may have been familiar with the systems that have been dug up, you'll have these really long white pipes with holes in them. Okay, maybe 40, 50 feet long. And the chamber system are like these pots that are out in sequential, right? And so I believe that the concept is that it takes a smaller footprint, doesn't it?
That's the concept. Some counties will allow reduction of field.
Yeah.
If you use chamber, some will not. It depends.
And some contractors prefer to do one or the other because that's just what they like to do. Now, Mark and Brett, if you would, if you would maybe weigh in here, talk to us a little bit about field systems and what you guys prefer to see. Without getting into too much detail on soil conditions, we're going to talk about that in a minute.
Well, in reference to some of the recent points here, I would like to point out that the St. Joe County Health Department does require a permit for working on the D-box. As Shane said, some counties don't require it, but we do.
Right.
Additionally, we do not allow for reduction in system size based on chambers. Some counties do, but not in St. Joe. The typical septic system absorption areas are the chambers, but we do still allow pipe and stone. A lot of times contractors don't use them because it's big, bulky, and it's a pain in the rear to put in. That's why the chamber systems are more popular, but there's nothing against doing a pipe and stone system if that particular contractor wants to. We do have to do pressurized systems sometimes if there's an existing system that's too deep, or if there's bad soil conditions to the point where we have to remove a bunch of soil. If we have to create a big pit and we have to fill that pit in, then the system will be pressurized. And then we also have mound systems for when things get
Okay, Mark, define pressurized. What do you mean by that?
Oh, I'm Brett.
Sorry, Mark's over there.
So pressurized systems, so when you have a pump, we're either flood dosing it to the distribution box and then it's gravity from the distribution box out. A pressurized system actually has pipe all the way throughout the septic system. So that way we know that effluent is getting the entire way. So with the chamber system, since it's gravity throughout and because they're the half dome of plastic, the effluent just dumps there in the front of the trench and then progressively throughout the years goes along the trench length. A pressurized system, we actually have, inch to inch and a half laterals that go the entire length of the system that have holes in them. And that then the pump pressurizes the whole system and evenly distributes that effluent over the area that's been excavated.
Why do we do that, and what are the specific conditions that create that situation?
So those questions are intertwined in the sense that, let's say that we have an existing septic system that is already 4 foot deep and it's failed. Well, the code only allows us to go 48 inches deep on replacement systems, and so that's no good. So we have to dig all of that out and get rid of all of the gunk and create a new interface from the septic system to the soil, so that way it'll repercolate. Same as if we had a bunch of fill soil. I mean, if there are certain areas of the county, certain subdivisions where they were not super well developed at the time, and septic systems were put in fill soil, and it didn't work out very good. And we don't want to redo something, or we don't want to repeat mistakes. So we want to get through all of that fill soil and into good virgin soil. So we have to remove all that. So we end up with this big 4 foot or deeper hole in the ground. Well, like I said, we don't want our effluent going in super deep, because then oxygen can't get to it and the system doesn't last as long. So we bring in sand, clean sand, to fill in that gap. And because it's clean sand and it's not soil, it's not necessarily going to treat the effluent super well. And so we want to pressurize that system so that way it's getting all across that sand.
Okay.
And it has then it gets a little bit better treatment before it gets down to that soil interface.
Carla, let's go to the next slide, please. Okay, so what he's talking about is percolation, which is and Shane can talk, he can actually talk for hours about this one, where that as clean as possible liquid that's going out into the drain field filters down through the soil and rocks and whatever else is down there, and eventually gets to the water. And that's what Brett was talking about, where when you fill that old system area up with sand, it's now it's not slowing down and filtering like it used to. Because at the end of the day, based on this visual, which is in fact a dumbed down version of what's happening, we're filtering poop water so that it can make it over to our well and we can drink it again.
Exactly.
It's a bummer, but it's reality, folks.
The soil conditions are extremely important. It's natural soil. We can predict a little bit about how water moves and how water can be treated. When you have filled soil, you can't really predict the hydraulic or movement, hydraulic conductivity or movement. And the compacted soil has a variable rate of anything stored or moving around. So the spec 23 sand, the engineering sand Brett was talking about, is a predictable sand. You know how fast water moves. So you spread it over evenly over the whole thing and not overload in one spot or another. It will allow it to evenly percolate down. The oxygen in there will help eat all the yucky stuff out of there. And then when it hits the soil, that it goes either too fast or too slow, it will be mostly treated, hopefully. And then by the time it gets to the groundwater, it's supposed to be clean. So that's the whole idea. And
the goal with this presentation is not for everyone to run home and call Tony Spencer for a whole house RO system. Okay, it's really this is how it works, and it's okay. It's okay to drink the water. Yeah. So Brett, back to what you were talking about with going basically replacing a system where an old system was. We would only do that when we're limited by space, right? I mean, because there's nowhere else on the property to put a new system.
Right. Whenever possible, we want it to be as shallow as possible, and with as little other stuff going on as possible, because we want that oxygen to get to the system to help break things down. So if we can put it somewhere else in virgin soil, let's do that. But if we're in these tiny little quarter-acre lots, and we've got decks and pools and other stuff in the way, and all we have is where the old system is, I mean, I'm not going to condemn the house. I'm not going to tell you can't live there anymore. We're going to figure it out. And so we're going to make something work, and so we'll put it back where the existing system was. Well, it's less than ideal, but it's what we've got.
Well, and that was going to be one of my questions to you guys. Mark and I actually talked about this a couple of years ago, and since, you know, that particular, and I don't remember what the subdivision's called, but that particular area behind Weichert Realty, you know, 23 in Ironwood, back in there, 35th Street and Bola and all those back in there, where they've got those tiny lots. They're on well and septic, and they're failing.
Yeah, Maple Lane is not a good. It is not fun for. Yeah. There's a couple areas of the county that are not fun on our end to figure out, and that would be one of them.
And so that's an instance where this pressurized system might be a good fit, right?
There are pressure systems there in that lane.
Sure. You mentioned a mound system, and I think for a lot of the people in our side of the business, that just gives them anxiety and makes them start to break out the cold sweat and kind of freak out and start drinking. So explain why sometimes in this county, a lot of times we talk about a lot about mounds. Explain why that might be in the different types.
So the most typical reason for a mound would be to get us away from the water table. I mean, if there are other adverse conditions within the soil, then you know, we want to stay away from these limiting layers. 9 times out of 10, the mound is because of the water table. Or our water table is super high, we don't want to put a system in the ground, because then we don't have, like on on your slide there, where it says percolation and there's the arrows going down. Well, there wouldn't, it's not going to percolate if we're putting it directly into the water table. That's, and not only is it not going to function, we're also polluting the water table. So we want that mound system to create that separation distance. Again, we're using Spec 23 sand underneath pressurized laterals to help filter through some of that effluent to try and clean that water up before it gets to our water table. There are other, some of the other times that we need a mound, even if there is enough slope for a perimeter drain or whatever, which I'll get to in a moment. But certain soil conditions, like compacted glacial till or effervescent till, it's for all intents and purposes the soil equivalent to bedrock. I mean, if there's no point in dumping water onto this compacted clay soil because it's not going to go anywhere. And so again, we have that mound system to create that separation distance to try and give us a spot for all that soil to seep down in. So sometimes we can get a perimeter drain around that area where we can lower that water table and we can create a space for subsurface seepage. But if we have that compact till, it's not going to seep, and so we have to go back to doing the mound system.
Okay, so Brett's getting a little technical there with some soil words, which for the most part we will never get into. But basically what he's referring to is where I live in southern St. Joe County. It's almost impossible for that stuff to get down through the soil because it's such heavy clay. And why in Granger or the northwest corner of the county, it's easy peasy because we're primarily sand and gravel.
Right. Just like pouring a bucket of water on sand, you know,
Right.
it'll go away, pour a bucket of water on dense glacial till or compacted material, high clay content.
It just runs off.
It just runs off, spreads a long way.
That brought up another point, but my brain just kind of went on reset. But I want to ask, and I meant to do it on the last slide. Carlin, does anybody have any questions? Does anybody want to speak up? If there's anything you don't understand, we've got a wealth of knowledge here with the guys at the health department and Shane. I'm just a facilitator.
So we have one question from Pam Proctor. I'm not sure if it's relevant for this, but it says, what can we expect the turnaround time to be once the soil borings are submitted?
Well, why don't we back up a little bit and let's talk about soil borings, okay? What are soil borings, Shane, and why are they important?
Well, actually the soil work itself, soil physical features have to be identified based on the rules starting in 1990. You have to identify all layers from the surface down to at least 60 or 80 inches. The design of a septic system is based on the number of bedrooms in the house, which equates to water use, 150 gallons of water per bedroom per day, and the soil conditions, how the soil is put together, how much clay content's there, what kind of limiting layers. There's limiting layers that cause water to go too slow. There are limiting layers that cause water to go way too fast. There are limiting layers like the water table itself that can be moved around, but you still have to stay above these limiting layers. So you got to identify those on the site with the soil evaluation. Usually the soil evaluations, you know, that process is not that difficult. Go out there and they pour it over the ground and they send it to the health department. So as far as what happens after that, the health department has to evaluate the soil borings, determine based on the code and the rule what can go there and what they will allow, and then they'll issue a specification letter, or I think they used to anyway. I'm sure you still do a letter what's going to be required. Then the contractor has to look at that letter and determine whether they can do that or not. And then if they can, then they submit bids. If they can't, then they go back to seeing what they can do.
Okay, so that's a multi-step process. And back to Pam's question, and Brett and Mark, what's the typical turnaround on that where someone gets soil samples, whether that be the realtor facilitating it or the homeowner getting their own or whatever's going on, and getting that to you guys then to make a recommendation and go to a contract?
I mean, it varies. Typically, we try and get them turned back around within a couple of business days. Like you had said at the top of the meeting, it's the health department in the middle of a pandemic. We're a little busy, and we're doing the best we can, but I can't guarantee you that you're going to get them back the same day, because because we're looking at, you know, a soil scientist report, we're more or less looking at the engineering of the soils. And so it's not necessarily always going to be a quick cursory glance and here we go. It's going to be, we're going to review this, write them up, have somebody else double check it, make sure we didn't miss anything, and then reissue them. And so, you know, if we get the application in, and try and get it processed within a day, because we are getting a ton of we always get a ton of applications. So we try and get them put into our system within a day, and then have them reviewed within a couple of business days, because we don't have somebody who sits in the office and that's what they do is review these. It's our field inspectors are also the ones that are doing this. And so if the inspector is out all day trying to do installation inspections, and then they got to come back and try and do, you know, write up these specs and then get them on to somebody else, if they're busy, you know, we kind of snowball. So we don't want to hold up process, and we definitely want to get these through, because this is the linchpin. This is what starts the whole chain. So we don't try and hold them up, but at the same time, it may not be as immediate a turnaround as desired from the outside.
Well, and so oftentimes there's extenuating circumstances like a lot size, or, you know, more things need to be researched, or you guys might need to go out and actually do a site review or something like that. But when we talk about these soil borings, who does that?
So we have a list of registered professional soil scientists. You have to be there's all sorts of credentialing involved to be a credentialed registered soil scientist.
Right.
And I think we've got not quite a dozen of them registered for our county.
Right.
Not all of them that are registered actually come up and work here, but there's a handful that, you know, do a lot of the work. Right. And they'll go out there and they'll do typically three or more soil borings for us to evaluate. And so we want at least 3, and sometimes we'll ask for more, because depending on the site conditions, those borings may give us different information that we need to take into account, because we want to choose the most restrictive of those borings. For example, the Gilmer Park area, so just, you know, where Old 31 and the bypass meet, the soils there are all over the place. And you'll get some soil borings where everything looks great, and you go to the other side of the yard and all of a sudden things are not okay. And so we want to make sure that we see that certain parts of the yard are not okay, so we don't spec out a system and put in a system that only half of it's going to work. We're going to want to see that the area where we're putting the septic system in is going to be suitable for that septic system. Okay.
Okay, so the soil scientists can be obtained from you guys. Is there anything online with regard to that, or
you?
Okay.
There is a list on our website of the registered professional soil scientists.
Okay, so somebody hires one of these soil scientists to go out and dig their little holes in the ground, and then do the soil scientists automatically send you guys a report, a standardized format of some sort, or do we need to do that?
No, the soil scientist report is typically given to whoever ordered the report, and then it, along with the application fee, is turned into us.
So can we do that application online, or do we have to come find a parking space at the county city building?
Either way, there is a mechanism to submit it online, and we are working on a way of streamlining that process, but there is still currently a process for submitting online. Or if you want to come visit lovely downtown South Bend, you are welcome to do so.
I don't like having to give the officer my gun at the door, so okay, so all this can be done online. What's the fee to have you guys do that evaluation of the soil thing and make a recommendation?
$275. I think it's $275
for the replace, or
yeah, for a system for a permit that's going to require the field system to be replaced.
Right.
It is currently $275.
Okay.
And then repairs are $150. And if you need a permit, but it's not going to require replacing the field system, like if it's going to be a tank only, that's only going to be $150.
Okay. Okay. So what you're saying is that clear at the beginning, if all, because I'm thinking about this in terms of our realm. Oftentimes we're negotiating things, you know, we're not actually thinking in terms of actual work being done, but to get to, and Mark and I talked about this is always a little bit of a dilemma. In essence, what we have to do is apply for the permit, even though no work may be done in the near foreseeable future, because it became a negotiating point between our buyers and sellers. Am I correct?
Yeah, and typically what happens in that case is the buyer or the seller will get an estimate based on the soil report and the specs that we issue. They'll take that to designer, they'll figure out what type of system would go in there, and then they escrow 1.5 times the amount of that replacement system. And then it's completed after the closing, and then the buyer would get anything, or the seller would get anything left over.
But I want to point out that it does not matter to the health department who pays for this septic system.
Right.
We don't care as long as it gets resolved. So
Right.
if you want to take care of it before the final, for the point of transfer or after, that's up to you guys.
Well, and that's one of the main points up here. You know, we started diving into all these little nuances of all the little terms on the slide here. When you look under, the first bullet point is disclosure. Okay, and there has always been this sort of anomalous weird thing in this market where if ever we got any sort of a failure on the old form, holy crap, the sky's falling and we need a $20,000 mound, and oh my God, it's the end of the world, what am I going to do? Sellers are freaking out. At the end of the day, this entire process is for disclosure. Okay, it's in this case the health department. It's the government saying we don't want anyone to buy a property without knowing what they're getting with regard to water quality and public safety with regard to a septic system. That is, at the end of the day, that's the whole point. Now, as it happens, the only mechanism for updating and fixing systems in this market is when a property transfers, you have to get it inspected. So no one would know. Interesting story, sorry, I'm gonna tell a story. I sold a property in the city of Elkhart a number of years ago. It was one of my auction properties that had never transferred title since it was built in the late 1800s. It had been in the same family the entire time. And through the process, almost right up to closing, we had no idea that it wasn't ever hooked up to city water and sewer. It literally still had the 2-inch well in a well pit and its own septic system in the backyard. Now, the investor that bought it was fine. It's, you know, they dug up, tore up the sidewalk and tapped. But the point is that because it had never transferred ownership, no one ever checked or looked into it. So just the point that the reason for this and the reason that we have this rule to inspect these systems and you know, water quality and all this is because otherwise it would never get done. They would have to go door to door. So this is the best mechanism we have. But again, it's disclosure, kids. It's not an us and them, who's going to pay the 20 grand, and that does become an item if in fact a system does need to be replaced. And it's kind of worst case scenario, but oftentimes it's purely a disclosure issue. So just keep that in mind as you're entering into these situations. And it's always a surprise for sellers because all they knew was they flushed the toilet and stuff, you know, when it left the house. They don't know any different when in fact it's bubbling up in the woods, you know, 50 feet behind the backyard. So I'm trying to think if there was anything else I wanted to bring up here. We do have a couple of visual aids. Let me see the next slide, Carlin. Sorry. It's been a while since I've been through this. Oh, before we do that, let's go back one slide. Sorry. And we do have a couple of visual aids here that Shane brought along that will help you guys understand some of the things that we're talking about. You want to hit that?
Yeah, we were talking about septic tanks quite a bit and what the septic tank does, its function. It also should be accessible, based on a couple of years' rules. You have to have certain radius of diameter of riser to the surface at grade. You also have to have a couple components within there. And you'll see the most recent septic inspections, you're having a lot of public health threat failures because of lids or internal plugs and a few other things that are not actually in the tank that should have been. The actual rule started in 90 for those things, augmented in 96. But prior to that, with discussion with the health department, they would like all tank accesses to be absolutely safe, which I agree with. So, and I was going to show you a few things of what the risers looks like and how you access them.
So while he's grabbing that, Carlin, if you would go to the property transfer septic and well report, it's 2 slides from there, I believe. 2 more, yep, 1 more, yep, there you go. Go ahead and hit it 2 more times. Yeah, okay, so one of the things that changed, and I'm sorry, I got a lot of sequence, and this is all Mark Espin, okay? He knocked this out of the park. Our old form used to just say pass or fail, and it never made any differentiation between what I would call like a technical failure, or in the verbiage that's used here, cautionary aspect.
Fixable failure versus
fixable failure versus 20 grand, okay? And in fact, even some of the public health threat aspects, which are like the real big deal stuff, oftentimes are fixable as well. But the point is that one of the coolest things Mark did was change this form so that it's more descriptive to everybody in our business, including homeowners who would just get this thing and be like, oh, it failed, oh my God. And they wouldn't read any farther to understand what's going on. So go.
Those septic tanks in the past, most of them have accesses on the inlet side, outlet side, or sometimes in the middle. And they could be all over the place. But each access has a concrete plug that's usually 4 to 6 inches thick, and it has a variety of shapes.
That's actually down on the tank itself, 2 feet underground.
2 or wherever it is underground. Yeah. Historically, the pumpers were like, well, can you got to dig that out, you got to always dig it out to pump it out. And so in the past, let's put a riser on here, make it easily accessible to the pumper to get there. So they typically toss the plug out.
That was the point, just to make it easier to get it.
Make it easier to get it. The trouble is, if you pull the plug out, depends on which one it is, there's direct access to, falling the tank, which is actually a serious public health threat. So
children can fit through the hole.
And the rule in 1996 was actually developed because we had a child in Fort Wayne fallen in the tank and died. And there was actually one in Roselawn did as well before that. So the rule is made that you should have 18-inch access to the surface and have an internal tank plug or an internal safety device and a tight-fitting lid. So people in the past, they did what they did. So what we look for is you go out in the yard. If you see the riser, then you got to make sure the lid is secure. This is a lid. This is a certain brand. A lot of people use this one. And I'm going to say it's the lid fits on top, and there's 6 screws that screw it down. I like these because you can pull the handle up. So inside this riser, you'll see the tank. The tank may or may not have that plug. If it does not, it'll be open right down there. You can see the tube right away. So if there's nothing there between the lid and the tank, it's missing an internal tank plug or internal safety device. So if you have Polylock or some other brand hub type, this is an internal safety device. This is a simple one, $20. That's all it is. And it fits right in here, and then you're done. If you don't have it, it's a public health threat. If you do have it, then you're good to go.
Right. And the reason we're bringing this up is, and this is sort of a loaded thing. Mark and I have talked about this. Shane and I have talked about this. Again, it'd be fun to have a show of hands. Some of you may be seeing on some of your septic inspections, it's literally, it's technically a public health threat line item, but failure due to lack of a tight fitting lid or internal safety device. And those are sort of, unfortunately, synonymous terms oftentimes. And this is where, you know, I'm a huge proponent of it. I go out on all my inspections. I know we're told not to, whatever. But when you're standing there, don't drop your phone in the tank, by the way, I've done it. When you're standing there looking down in there, you'll understand what it is they're talking about when there's no plug in the tank. Now, my plug in my tank is only this big around, okay? I can barely fit my arm down in it. A little kid's not gonna fall in it. But technically that should be covered, okay? Even though I have a riser with a lid that's screwed down on top. So the point to this is, if you get a failure, and before you have the anxiety attack, read on and see that it says something about a tight fitting lid. Shane, say somebody doesn't even have a riser and you go to this system. What does it cost for you to grab that out of the back of your truck and install it for somebody?
I just bought all the parts this morning, $180. This is the adapter plate I like when I do it. This adapter plate fits nicely on the concrete. I don't like to tap on the concrete. I use, this is called Mastack tape. I call it Gorilla Poop tape. Right? 2 round lines around and it fits on the tank type seal. You'll see a lot of times I'll say there's roots in the tank to the riser because the riser wasn't installed correctly. This will keep all the roots and water out. The idea is you don't want roots, folks, anything in the riser, so that's what you do that.
But installed, what are we talking dollars?
Most people around $200.
Right.
I try to tell people how to do it, and then I'll give you the parts you can go do it.
So oftentimes, and I've had this situation with Shane where I'm standing there with him, and we've got this condition, and he says, you know, I'm here. I think most of you are like me. I'll eat the $200 if I have to just do it while you're here. If he's got the parts, knock it out. And any one of our inspectors or septic contractors know about all this stuff, and it can all be done. Now, what about an older system, Shane, where it's a 12-inch riser like I have? Yeah. They don't make the plastic thing. I don't want an 18-inch thingy out in my yard. The wife will drive the mower in it. It'll just be a nightmare. So what can be done for that?
Well, there's a 12-inch lid. There's a 15-inch lid. I got an 18-inch lid. There's different types of lids you can use to put on top of the riser. But that still doesn't solve the internal plug problem unless it's there. One of the components, actually, the health department here suggested this material. This is
they're here to help.
Yeah, this is an internal safety device. This particular one is a 24-inch one. This is for dose tanks. It's designed to you screw in the side of the riser, bolts from the outside. It has these rings where you can loosen them up and fold them back for maintaining pumps or
without disassembling
the whole thing. I didn't have any of the 12 to 17 inch ones, but it's wildly popular. The 12 to 17s, they have less ones, but they have the 12 to 17, that's $30. This is here is $42. This lid, interesting enough, is $40-some. This whole riser kit's $20, $40, $60, $80 right there.
Right. So we're not talking about prohibitive dollar amounts here. What's the blue thing laying here?
No, that's a kind of a different story. A lot of times when you do a septic inspection on a modern system, and that 2012 newer required outlet filters, but there have been a progressive contractor before that like outlet filters. Right. You open the tank up, and it's like, wow, this is high level. First thing you got to check is whether or not it has an outlet filter. A lot of times, homeowners don't know about these things.
That's because they're gross. We don't want to mess with that stuff.
Yeah, I put a lot of information in the septic inspection report about these. This is an outlet filter. This is a new one. I'm not touching a dirty one. Just saying. This is one of mine at home. But this is called PL122 filter. It's designed to filter all of the sediment, reduce the suspended solid load from the tank out to the
so this would be in essence part of that outlet baffle that we discussed. Okay.
Yeah, and it's just disgusting. At home, I do a hazmat suit. Yeah. You pull it out, black junk falls in. You have to wash it off in the tank. You can't put it outside the tank or anywhere else. You have to keep the biohazard in the tank. So, and these things you gotta clean 3 to 4 or more times a year.
Really?
Otherwise, you'll back water up in the house. So many times I pulled filters out, You gotta pull them slowly so you don't flood the system with solids. This type of filter has a ball that shuts the water off. That's
so
why you
3 to 4 times a year, once a quarter.
Yeah.
And knowing about how we maintain real estate in this part of the world, how often do you inspect systems that has a filter and it's been maintained ever?
Lots of times.
Really?
Actually, I was thinking the opposite.
Yeah.
It's rarely where I inspect the system where you pull this out and it's clean.
Yeah.
Rarely.
Right.
Especially these. This is another type. This is what I call a splasher. You pull these out, these bristles, they shoot poop everywhere. I hate it. So I got a long pole. But this is another type of filter. This is the older style. There's they like these, but these will get clogged with sediment, and it's absolutely disgusting. It'll hold water high in the tank, so the water will go in back to the house.
Okay, so let's talk about sediment for a minute. What is leading question, right?
Yeah.
What is the leading cause of that black gook that they talk about on TV, where you have to be afraid of? And is that literal poo out in the drain field?
Yeah, it's decomposed organic matter. Is basically what it is.
What about laundry soap?
Laundry soap, those generally turn into fat soils and greases part.
Okay.
And that stuff you can see it on the side, and it'll crust up soils. This will hold it. This will hold it back.
Okay. If it's maintained.
It's maintained.
So the takeaway here, kids, all right, is, you know, we're the frontline folks, and you know, we've got enough on our plate, certainly, of all the things we have to worry about with St. Joe County addendum and lead paint addendum and radon and all this other stuff. But you know what? We get paid really well to do what we do, and there are a lot of people that have never owned a septic system before, that you are going to sell a house, it's going to have a septic system, and everything may check out fine, but you know, it's real simple to bring things like this up, to mention to them, now you know, this is something that needs maintained. They're probably not going to do it themselves, but they can pay a guy to do it, okay? And come, and this is something that a lot of us don't think. I don't do it myself near enough. So it's something that we can be mentioning to people, which adds value to what we do.
All right. Here's another thing. My short story. I did a septic inspection last year, had an outlet filter, and in my septic inspection shows each picture, each stage of how you maintain an outlet filter. I got a call probably 6 months later, said my tank's failing, my sewage is all over the ground. I said, have you pulled your outlet filter? And he said, I didn't. And the guy said he didn't know what it was. I said, did you read my soil report, my septic inspection report? And he said, no. I said, read that and take a look at it. He hadn't pulled it. And the other thing is, in the septic inspection report, it says no wipes, no anything other than toilet paper and human waste. And the septic pumper pulled 3 garbage bags full of wipes in 6 months.
Nice.
And it's like, you got to read the reports too to know that this stuff's in there.
What's the easiest way to know if it's a newer type system and there is in fact some sort of a filter?
I always request documentation from whichever health department I'm doing work in. So like St. Joseph County, if I have a septic inspection request here, the first thing I do is I send a request to the health department asking for the schematics. So Letitia or a few other people will send me those. They will tell you if they have them on file what it is.
Right. But I'm looking for the dumb down easy answer for a realtor when we're standing in the family room for the first time showing these people this house and we're looking out in the backyard. What are we likely to see?
You will see a riser lid. You have to have that. And well,
you'll see 2.
You should.
Typically.
You should see 2.
Right. If you see 2 lids, it's guaranteed there's a, right?
Yeah.
It's guaranteed there's a filter. Now there still could be filters without the 2 green lids, but if you see 2 green lids with no dosing mechanism, you know that there's a filter, and that's
there are some houses that have filters that have buried.
That have buried the other end of the tank.
I've seen that.
Go ahead.
How, so somebody asked a question, so to clarify, as part of regular homeowner maintenance, homeowners with septic systems should clean that filter how often?
Once a quarter.
Yeah, once a quarter. And the homeowner will get a familiarity with, how do I say, how dirty they are. You know, I try to do mine 4 times a year. Last year was only 3 times. I guess my family and I were less dirty last year. But the year before that, it was 4 times. But I always go and pull and look. And a lot of times the contractors will have a handle to make it easy, so you can just pull it out and take a look. And you can never take this one out and leave it out, because it'll cause problems with the ball in there to stop the water.
Yeah, it literally is a check valve.
This one here, you can pull out, and these are $20 and these are $34.
You don't see those very often, though. It's almost always this.
Certain contractors love these.
Really?
In
our market?
In our
market. Okay, well, there you go.
This is their thing.
Okay.
There's another one that's got a seal, it's similar to this.
Right.
But it's important to maintain for the keeper. So when I say your tank it fails a cautionary statement because it has high stains and it has a filter, I pull the filter, make sure the water runs, pull the filter back in, make sure the water runs. The filter itself is the one that's causing the high water. So that cautionary statement is for the buyer to know that this can cause high water. That's why that's a cautionary failure.
Right.
Which is a good idea.
Right.
But everybody goes, oh, it's a failed system. How do you fix it? It's like, it's not a failed system.
Read.
Just read the rest of the verbiage.
Right. And on that note, I don't know if everybody saw those 2 pages of the new and improved inspection report. I would assume or hope that most all of us have seen it in real life, right? Like when we've gotten transactions on houses that have well and septic. Are there any questions on that form or anything that we've talked about with any of these? That we're throwing to some of you, there may be a lot of new words: risers, filters, pumps, effluent, whatever.
Somebody did ask for Shane or another contractor, what's like a typical charge for cleaning that filter?
I don't do it. It'd be $1 if I had to do it. No, actually, when I do a septic inspection, if the filter is inhibiting proper function of the tank, I'll just wash it off in the tank, but I don't do a proper cleaning. I say the filter needs cleaned and the tank needs pumped. This is what I say. That usually the septic pumpers, the ones I know will clean the filter for you and they do a good job. The problem is they're only there every 2 to 5 years.
Right.
You have to do it more frequently. There are service providers out there. There are septic service providers that will do that. They have a monthly fee or an annual fee.
Who does it? Does A&R do that?
Yeah, they're one of them. I think Abe does it. Maybe Walt does it. I don't know.
Yeah, Lincoln might do it. I'm sure.
Hawks might do it. I don't know who all does it, but it's there are people that you can pay for that. I personally would pay somebody to clean my outlet filter.
Totally. Yep.
That's disgusting.
It's gross.
So we have 2 additional questions. Somebody asked, why are older systems often considered given a cautionary pass, even if they look super clean and in excellent condition with excellent maintenance?
I've never heard of that. If they pass, they pass.
Well, I know what happens, and I know who does it, and it falls under the category of, and we can all understand it if I explain it this way, like whole house inspectors that feel like they need to throw everything out there because either they've been sued or they're afraid of getting sued.
Well, here's the way you're supposed to do a septic inspection according to the state is the septic system has to have the permit and match the age of the house. So if the house is built in 1978, you have a permit for that system that's 1978 is installed based on the rules closest to that permit, which would be the 1977 law. If the 78 law wasn't out yet, you go with the 77 rules. If it matches the 77 rules and it doesn't violate any of those cautionary or public health threats, then it passes. And it can function forever. Age is not really relevant on a septic system. What's relevant is how you take care of it. I've seen systems that down southern, well, all over the place. I've seen thousands of septic systems all over Indiana. And I've seen ones that are 2 years old that are blowing up the top. I've seen some that are 60 years old that look like they're just brand new. And it's completely how you maintain it. That's why in my report, I tell you what to do. No excess greases, none, all this stuff, no rubber duckies, and all that other stuff. You got to maintain your system. You got to know where it is. That's the main function of having a riser there. The riser allows you access so you can actually visualize and see and maintain.
Without digging a hole.
Without digging a hole. Out of sight, out of mind usually is a bad sign.
Right.
Every time I got to dig 2-3 feet to a tank, it's not that. It's
not
that good because no one wants to dig that deep.
Right. Right,
So,
and he can tell if that dirt's been dug before.
yeah.
I know.
Yeah.
So hopefully that answers that question. If not, please reiterate.
And then I think we discussed it, but somebody asked, what's the general fee for the soil borings? I think Brett and them went over that.
Brett or Mark, I can't remember the last time I had Tim do one. It seems, for some reason, it seems to me like it's like 150 or 200 bucks.
So the permit itself is $250,
Right.
but that's on our end.
Right.
The soil scientist, that's basically a subcontractor, and those prices are going to vary depending on the soil scientist and market rate and all that. Typically, it's $400 or $500, give or take a couple hundred, depending on what's going on.
Okay. I was mistaken. Right.
Yeah. So.
And then the last question that I have, it looks like right now, what is Shane's recommendation for using products like Ridex on a monthly basis? They've heard conflicting recommendations.
All right, well, I'll talk on the chemistry side of it. So I'll try my best. Okay, so everybody watched Sesame Street, right? Cookie Monster on Sesame Street. That Cookie Monster eats those cookies and goes crazy, does a good job of eating cookies. But you see the cookies all over the Cookie Monster's chest. So he breaks down the cookies good, but he doesn't get them all completely broken down. So you put Ridex in the septic tank, which is designed to store, trap, and precipitate solids out. And all of these suspended solids or remove suspended solids out of liquids to go out into the absorption field. If you put Ridex in the tank, it's like the Cookie Monster. Ridex does an excellent job of breaking down organic matter, oxidizing it up. The problem is the particles are small enough that they'll get through all the baffle systems and large enough to clog the soil. I personally put Ridex in my septic system, but I put it in my D box. I have a riser to my distribution box. So my tank is over here, my D box is over here, and my leach field is out that way. I put it in my actual D box so it oxidizes the organic matter, gets rid of the organic matter.
Any organic matter that is getting in there is being broken down. And
it's broken down on the absorption.
Interesting.
So I personally wouldn't put it in the tank. I personally wouldn't put it in down my toilet. One of the Ridex functions is to clean your pipes inside the house. I mean, that's a good argument, but I think it adds way too many suspended solids to the absorption area, and the absorption area is a fickle environment. You don't want to clog that soil too fast, because then you got to replace it. And as Brett was talking about how challenging it is in small environments with a lot of houses to do a best fit, best case scenario for a new septic system. That's part of what takes a while, is trying to figure that stuff out.
Right, exactly. And that is an interesting, I want to know if we have more questions in a second, Carlin, but that reminds me that that's an interesting segue into one of the things I've been preaching for years. And that is, as far as I'm concerned, the moment that you know you've got a well and septic property, get it inspected. There have been a few times where people argued enough that I paid for it, because I don't like having surprises, and I know none of you do either. And the surprise is going to happen when you're midstream in a transaction. There's enough other crap we got to worry, no pun intended, that we don't want to deal with that too. So I always have them inspected ahead of time, because how often do we need an inlet baffle or a filter clean or a lid tightened down or whatever? And that's super easy. And then you've got the clean bill of health after that, and nothing to throw a red flag at a buyer. And if it is a weird situation and it's going to take a lot of effort on the health department, contractors getting involved in site visits, you're going to hold up a transaction if you didn't go through all that ahead of time.
I was at a lot of them, usually quite a few a day. I was at one of the homeowner races. I don't know why we're doing this. My septic system's fine.
Sure.
Literally, absolutely was aggravated that I was there. So I said, "Come on, let's go take a look at it." We went around the back of the house. The backyard was flooded with sewage. I popped the lid, and he had a lid and he had an internal safety device, which I was impressed with. But there was sediment and unmentionable sitting on top of the plug, so I pulled that out. And it was a disaster. The whole thing was a system failure, and he actually didn't realize that was a problem.
Right, because again, he flushed the toilet and stuff went out of the house.
I'm surprised it did actually.
Right.
So homeowners, I always say homeowners tell you 100% of the time that it's just fine. And so we've got to do a little bit more. If you're going to do a pre-listing or something like that, just look a little bit further. Sometimes you have to contact the health department if there's problems. If you got environmental health, you got to go through the permitting process to make it right.
And they're here to help. Okay. I don't think I'm speaking out of turn by saying you can pick up the phone and call Mark or Brett and say, this is what, you know, we're experiencing. What should I do next? Hopefully this presentation will help you understand some of that. But, you know, they're there to help, because at the end of the day, it's their job to help direct us as the public to have clean drinking water. And I do have Mark's contact information. I didn't have Brett's on there. But I think, Mark, that 245 number gets them into the system if they call, right?
Yes. Well, that's my direct number that you have.
Got it. So do we want that published or not?
That's fine.
Okay, cool.
It's on the website.
Yeah.
You can't stop it.
Yeah. Any other questions, Carla?
I got a question, Lance.
I don't.
Okay, go ahead, Jim.
Who's going? Okay. Yeah, this is Dale. Wondering if somebody maybe at the health department can speak to the proximity of the well to the septic system. Is there a number of feet? Is that from the tank? Is that field? And if it's all going down to the water table anyway, why does it matter?
Okay, so to repeat the question, Dale was asking about proximity of the drinking well to any part of the septic system. Mark or Brett?
The separation distance is going to be 50 feet for a residential. It's 100 for a commercial property, and then 200 for a public water supply well.
That's
separation.
That's the
And
state.
Go ahead.
Oh, yeah, I was gonna say, Dale, that's a state rule. It's a state mandate. You have to, any component of the septic system has to be 50 feet away. If your delivery line from your septic, from your house to septic tank is within that 50 feet, it has to be changed to a different type of pipe. So any component within, has to be 50 feet away, or the delivery line has to change.
Doesn't that vary with method of financing? Do you have any, isn't there something funny with FHA? Who's online?
One of our lenders is online.
Fantastic.
They want
75 feet for FHA. So there can be overlays that that are even more restrictive than our local codes. So we've got to be careful of that.
I was gonna ask Nate.
If that comes up, I do the grandfather letters. So if you have a situation where the well and septic don't meet the 50 feet or are at 55 feet and don't meet the FHA, you can submit the septic inspection report and the water test. And if everything checks out okay, and I'll review our records and our GIS, and then we will issue a grandfather letter allowing that well to stay in use.
Conditionally. I mean, that's not all encompassing. If your well is 15 foot from a septic tank, I mean, well, let's not get out of hand here.
Yeah.
But if we're at 47 feet instead of 50, I mean, we can talk.
Yeah, I was gonna ask you that because I see that every once in a while, and I tell them to call the health department so they can, you know, do the FHA waiver or whatever.
But that's fantastic. That's worth the price of admission, right?
Yeah, I don't like
Yeah, I mean, it takes a little time. We got to check the depth of the well to, you know, if it's a 35-foot well, you know, that's kind of sketchy. But if we're talking a 90-foot deep well,
Yeah.
then, you know, and we got some clay layers in between the surface and the where the well screened, we can allow that.
Yeah, there's supposed to be certification 10 foot of an aquitard or clay layer. You gotta be casing.
Aqua what?
It's called aquitard.
I don't think we were supposed to say that. Any other questions, Carla?
I don't have any other questions, but you are getting a lot of discussion from everybody, so it's pretty interesting to read, and everybody's got a lot of things and suggestions for everybody. It's been great.
If it's things like I should wear a different color, I don't want to hear about it.
If it's things like how you're gonna give me some maple donuts, I do want to hear that.
So,
No, Pam Proctor, she just said something very interesting, and said that she has had a septic for over 40 years. It was original. She maintained it, I can't even pronounce that, and didn't send stuff down the disposal and had it pumped every 18 months, and it's still working perfectly today.
I believe it.
So yeah, just proper maintenance, I think, is what everybody, Lori Ladow said that she tells homeowners they really need to set up a quarterly maintenance plan with a vendor. That's what she tells her clients to do and give them the resources for that. So
I would like to point out that a septic effluent filter is the most no-brainer, cheapest insurance you can have for a septic system. Like Shane said, a filter was like 30, 50 bucks, something like that. And everything that it's stopping is all stuff that would otherwise go out into the field system and plug things up. And so you're spending 50 bucks to put the filter in, and then a couple bucks here and there to get it cleaned off. And that's going to save you, depending on what kind of system you would need, $15,000, $20,000 on down the line.
Absolutely.
And a mild inconvenience to save you, 5 figures is a smart move.
That's an eye opener. My system was older when I upgraded mine in '95, and we used experimental chambers, and mine was an experimental site. But 2015, I moved my tank, and one thing I wanted to do is a riser on both ends. I want a riser on my D-box, and I also want an outlet filter, because when I pull my outlet filter, and I just imagine all that going into the chambers, it's a volume of stuff that will clog the chambers. And chambers are not, they struggle with recovering, where pipe and gravel recovers quicker than chambers because of the plastic louvers. You kind of get stuff wedged up in there.
Oh, that's an interesting point. Sorry to interrupt, but when we talk about systems recovering, oftentimes there are homes with a dual system and a valve. Talk about that briefly.
When I evaluate it, I like to look at both systems, run water on both systems, but basically you have an older system that was originally permitted, and for one reason or another, it stopped doing what it was supposed to do. So during the next permitting process for the new system, some counties allowed it, some counties didn't, but put a valve that you could switch or alternate from the old system to the new system. I think those are great, because now you have twice the absorptive area. The trick is you gotta, the new system can last longer. You can use 4 or 5 years on that one, or 20 years. But the old system, after 4, 5, maybe 6 years or 6 seasons, it's recovering well. What it's doing is the lack of water and the increased concentration of bugs in the air basically gets rid of the organic, and over time you can recover that system. So if you have 2 operating systems, run it every 4 to 8 seasons, change it, change them back and forth. So you let one rest, recover, get rid of the organic matter, and the other one be in use. And it's a nice thing. I think that's a good idea. There's a lot of counties that did a lot of that. This county has quite a few of those.
Do we allow that now, Mark or Brett?
We do allow that conditionally. I mean, if the old system is a tiny little old junky system, we're not going to do that. But if the old system, our rule of thumb is 75% of what the sizing should be, then yeah, we would definitely allow a valve to go in, and we would stipulate it on the permit. You got to use a new system for at least 2 years to give that other system time to rest. But yeah, we do allow.
Right,
all conditions.
You have to have space. And, yeah.
Okay, I just got another question. If a system doesn't currently have a filter, is it because of the type of system it is, or can one be installed?
Yes. If it doesn't have a filter, it's probably installed before 2012. Pretty much most systems can be, you can add a filter to it. There's some tanks, they're coffin tanks that you just can't, the lids are too big, and then you'll get with the health department with some advice on maybe putting a filter chamber on the outside of the tank. I don't know if there's specifications for that, but I've seen tanks that you can't put a filter in, but they've put a sump pit essentially with a filter in between the tank and the distribution box. But most of the time you can do that. Then you want to have a riser on the outlet side, because that's where it goes. You want to have the internal safety plug and everything accessible. But for the actual code, definitely the health department will help you out with that.
Someone else mentioned that they were on city water and still don't use the garbage disposal. So is that like an issue? Do people need to consider not using it at all or using it bare minimum or?
The garbage disposal, what it does is fluffs up stuff. It makes things float, and the floatables, if you don't have baffles in place correctly, they can get out and into the absorptive area and clog the soil. Generally, don't encourage the use of garbage disposal. If you're on city water and city sewer, then get with the sewer department and see what they say. But city water and a septic system, my suggestion is put a filter in there. That's one of the reasons why the filter was required. I think it's after 2012. Was that there was a lot of fluffy stuff getting out into the septic system, and you can't recover that real well. So that filter is designed to, if you want to use the garbage disposal, it will catch a lot of that stuff. So, and the filters itself, this whole thing, the housing and everything with this was like the baffle and the whole is $60. And so but then you got to pay somebody to get the poop, and it would really be $1 million. But if it's a regular contractor, they'll have normal wages. Yeah, $200.
We have gone long. It's 20 till 3, so I want to be respectful of everybody's time. But by the same token, we want to make sure, if anybody has questions, because it occurs to all of us, especially the education committee, that if any of us are better, we're all better. So, anything else?
Anybody is welcome to come with me to the field. There have been realtors that go with me all week long. They help out. I make them dig. I make them do. If you don't want to dig or anything like that, you can provide moral support, and I'll show you some of the stuff that I see. And all you have to do is see it once or twice, and then you'll get it. You'll get it. It's you'll know when things are bad, and you'll know when things are good. It's a lot of times it's pretty clear. Then there are those that it's impossible to get all the correct information. It's absolutely impossible. So it's tough. It's a tough gig.
Anything else?
I do not have any additional questions. I didn't know if you guys wanted to check with Brett and Mark if they had any additional comments for anybody or.
You guys?
I mean, feel free to give us a call, shoot us an email. We're more than happy to help you out. I mean, the way that the code's written, we don't get the property transfer inspection until after closing. And then when there's issues and we have to try and resolve it, then people are all freaked out. You are welcome to send us these property transfer inspections ahead of closing if you want us to take a look at it and say, hey, this is kind of what we're looking at. We don't want to create problems. I mean, that's where the health department, that's kind of going to happen. But we're more than happy to try and head things off early. So if you want to send us, you get a report in and say, this looks kind of weird, what would happen here? Feel free to let us know.
And I would just like to add, we get this question a lot. You can have a failed septic inspection. That does not mean the system's in failure. So you don't have to go out and order soil borings and start preparing to replace a system because it has a missing baffle, or the staining is high in the tank. Some of those are common failures, but it doesn't mean that the system's in failure. It just means there's a restriction. You need to pay attention, do some general maintenance, and it'll probably go away.
And that's cool that you guys offered to be a resource before closing too. It's sort of in our side of the business, and a good analogy would be call an area plan when you've got a potential building site out in the county that you're not quite sure about. You get a hold of them early on and they help explain what's going on with that parcel. And these guys are offering to do the same thing with these inspection forms. So that's fantastic. Thank you. Anything else?
Everybody's saying thank you for all the great information. And I did want to mention, where is that? Kathy Glassburn said she does not dig, but she will bring maple donuts.
I always ask and I get zero.
And then I do want to let everybody know we did record this session. So if you wanted a copy of the recording, I could send that to you. We are going to have something on our website, hopefully soon, an archive of any recorded events that we've had. And somebody also wanted Mark's contact information. I can send everybody that in an email after this is done.
Awesome. Thanks, Carla. Thanks for lining this up. Good job.
No problem.
Thanks, guys.
Okay, take care, everybody.
Thank you, guys.